Now talk about acid catalyzed esterification of acid anhydrides. So we're going to be taking acid anhydride and reacting with an alcohol. And as I was intimating earlier, I would say that if we were using an asymmetric anhydride and an alcohol as a starting material, we would end up with 4 possible products. Right, let's take a look at the mechanism for this. And you can see it again, it's following the classic positive mechanism that we've been discussing. You can see that the Y group is going to end up being this group here if we end up attacking this C double bond O first. You see that we will end up having a choice here of which C double bond O we end up attacking. So we're going to end up with different Y groups depending on which one we attack first. But if we attack this one first, then this will be our Y group. You can see what the X group is going to be. The X group is going to be this here. And you can see again that the X group has ended up replacing the Y group, and we get an H attached to the Y group. So I'll just put a circle around that, and we've got the Y group here, so it'd be YH right there. So it is following the same patterns as we've been discussing. I will show you the attack on the left hand side first. So the H plus will come in, attack the C double bond O, something we've seen many times before. And then the alcohol will come in as a nucleophile and attack the C plus. And that will end up giving us a positive charge on this oxygen. Now the thing is that we know that this Y group, which is the group that was originally attached to the C double bond O, is going to leave, and as we've discussed, we know that the leaving group will get the proton in the proton transfer step. And it's easy to identify the leaving group because it's what's originally attached to the C double bond O that we're attacking, so this entire group becomes the group that we know will accept the proton in the proton transfer step. Alright, so there's our proton transfer step completed. And now we can reform our C double bond O and kick out the leaving group. Alright, so there we go. There's our first 2 products, and we get that from attack on the first C double bond O, the one on the left. Let's just see what happens when we attack it from the right hand side. You'll see the mechanism is pretty much the same. So now the H plus will attack here. Now remember, this is only occurring because we have an asymmetric anhydride and an asymmetric reagent in the alcohol. Oops. And now the alcohol will come in and attack from this side on the C plus. Make that double bond a bit clearer. There we go. And again, to get the proton transferred to the group that's going to end up leaving, and the group that's leaving is the group attached to the C double bond over that was originally attacked. So we know that that group is going to be the leaving group, and we know that that's where the proton will get transferred to in the proton transfer step. And you can see that that's what's happening here. And then the C double bond O will reform and kick out the leaving group. And that gives us our products. And there you go. So that's the acid catalyzed mechanism. And again, you can see how we're getting our four products by the differing attack on the asymmetric C double bond O's with the asymmetric reagent.